Hello there, Mr. Sutton here with the AB Calculus 4-2 Extra Practice Number 1 solutions on increasing and decreasing intervals. On this problem, we're given this f function here. We want to know where this function is increasing. So to figure this out, we just need to figure out where its derivative, f prime, is positive. Let's get the derivative. That's going to be 4x to the third plus 2x. And to see where it's positive, we're going to solve for some critical values. So let's set this equal to 0. And to solve for x here, I can just start by factoring out a 2x. That'll leave me with, 2x squared plus 1. All of that equals 0. So I see that x is going to be, what I need for x to solve this is going to be the 0 for this 2x part. And then for this 2x squared plus 1, I can subtract 1, divide by 2, square root, and I'm actually going to get nothing out of that because I'm going to be square rooting a negative number. So really, x equals 0 is the only critical value for this. So let me test that out on my number line and do a little sign analysis. So here's my f prime number line. I have my only critical value at x equals 0. And now testing a number a little bit less than that, like -1. Now this 2x squared plus 1 piece is always going to come out positive because you're squaring and then you're adding a number. So it's really down to this 2x part in terms of determining the sign. If I plug -1 into 2x, that's going to come out negative. And then if I take a number more than 0, like 1, and plug that into 2x, that comes out positive. So I see that I'm increasing, which is what I'm looking for, on where f prime is positive. So that's going to be 0 to infinity. And that's going to end up being, let's see here, answer choice C. On this problem, we're initially given this f function, 3 minus 2x. And then we're told about a g function whose derivative is given by g prime right here. We want to know where g is increasing. So to figure this out, I need to figure out where g prime is positive. Let me start by rewriting g prime without all these f functions in here. So if g prime is all this stuff, then I can rewrite this f of x here as just 3 minus 2x. F prime of x is just the derivative here. This is going to be just -2. And then we still have this x minus 3 floating around. So this is g prime. Now, it's tempting to distribute all this out, but I don't really need to. I just need to figure out where this thing is 0 or undefined. And since it's all polynomials, this is just going to be 0 in terms of critical values. So just setting this equal to 0 and solving for critical values, I see that this is going to equal 0 where x is, let's see, for this first one, subtract 3, divide by -2, so 3 halves. And then, let's see, this -2 doesn't give us anything. For x minus 3, we can say x equals 3. So these are our two critical values that we're going to do some sign analysis with. So here's my g prime number line. I've got critical values at 3 halves and 3. Let me test a number in each interval now. So if I plug in something less than 3 halves, like 0, so that's going to give me, let's see, a positive, negative, negative. 2 negatives is going to end up giving me a positive. And then something between 3 halves and 3, like 2. That'll end up giving me a negative, negative, and another negative. 3 negatives is a negative. And finally, something bigger than 3, like 4. Well, now I've got a negative, and a positive. 2 negatives is a positive. If I want to know where g is increasing, then I need to know where g prime is positive. So that's on this first interval from -infinity to 3 halves, and this other interval from 3 to positive infinity. And let's see here, that looks like it's going to be choice A. On this problem, I'm given this f function whose derivative, f prime, is this crazy absolute value expression. They want to know where f is decreasing. So for this, I need to figure out critical values and then figure out where f prime is negative. So for critical values, I've got two types on this because we have a fraction with some x's in the denominator. So just thinking about where this is going to be undefined, if I plug in 2, I'm dividing by 0. So we can say f prime does not exist at x equals 2. So that's going to be a critical value. And now if I want to figure out where f prime is 0, I really am just looking at the numerator to see where that's going to be 0. So that's going to be 0 wherever absolute value 4 minus x squared is 0. And that is going to be 0 wherever I have either 2 or -2 plugged in here. And of course, positive 2 also makes the function undefined. So that's more of a whole than a zeroing value, but it's still going to be a critical value either way. So at the end of the day then, we have plus and minus 2 as our critical values. So let me make an f prime number line out of that. We have negative 2, positive 2. And now let's do some sign analysis. So I'm going to plug in a number less than negative 2, like negative 3. Now when you're doing your sign analysis, obviously here the numerator, because we have this absolute value, this numerator always comes out positive. So it's really down to the denominator to determine the sign of the whole f prime. If I plug negative 3 in, x minus 2 is going to be negative. If I plug in something between negative 2 and 2, like 0, well, my denominator is still going to be negative. If I plug in something bigger than 2, like 3, now I've got a positive denominator. So now looking at decreasing for f, I want to know where this is a negative f prime. So that's going to be from negative infinity to negative 2, and also from negative 2 to 2, so overall from negative infinity to positive 2. Now you might wonder, am I allowed to include this negative 2 critical value here? You are allowed to include it as long as the original function is defined at negative 2, and it is. It's only positive 2 where the original function might be undefined. So we are going to go with negative infinity to 2, which is going to give us answer choice A. For this problem, we have this f function given here, and we want to know where this thing is increasing, decreasing, all that kind of stuff. So to answer that question, I need to figure out f prime and figure out where that's positive and negative. So f prime, using our power rule, we're going to have 3x squared plus 12. And now I have to figure out where this is positive or negative. Well, I mean, we could set this equal to 0 and solve for critical values, but just taking a quick look, we're squaring the input here, multiplying it by a positive number, then we're adding another positive number. So there's no way this thing could ever come out negative. It's always going to have to be a positive number. This is always going to be greater than 0, which means the original function f must be increasing, well, everywhere. So always increasing. So that would be then choice C. On this problem, we have some function f that's increasing on the interval from 1 to 3 and nowhere else. They're also telling us the first derivative of f prime, is continuous. We want to know which of these could be a table for f prime of x. So if f is increasing on the interval from 1 to 3, that means that its derivative, at least on the open interval from 1 to 3, is going to have to be positive. And we don't want to have positive derivatives, positive f primes, anywhere else. So taking a look at our answer choices, a quick look at these tables. These are all tables of f prime now, so be careful with that. Looking down here at choices C and D, I notice that f prime of 0 in both cases equals 1. Now that's a problem because 1 is a positive number, which implies that our f function should be increasing somewhere between the interval between a 0 and 1 here. So this is a bit of an issue because we didn't want to be increasing anywhere else other than between 1 and 3. So because we're increasing outside that interval that they specified up here, C and D can be eliminated. There's too much increasing going on in these two tables. So that leaves us with choices A and B. Now you'll see in both of these that at 0 and 4, the numbers that are not included with 1 and 3, we've got negative derivatives, so that checks out. The only difference between these two tables is with choice A, f prime of 1 and 3 is 0, and then we have 1 for those values in answer B. So which of these is correct? Well, the key here is that they told us our first derivative, f prime, is continuous. Since f prime is continuous, that means we can't just jump straight up to positive 1 for the derivative after not having positive numbers right before that. It means that to get from negative 1 to positive 1, we have to go through all the y values, all the f prime values in between. Well, that means that I'm going to hit some positive values before I even get to 1, like 0.5 and 0.75 and all those. So for choice B, since I'm going to have to hit positive f primes somewhere between f prime of 0 and f prime of 1, that means that I'm also violating this condition of having an increasing function outside the interval from 1 to 3. So this is also going to be a no. And it's just choice A, where we can't possibly have positive f primes anywhere but between 1 and 3, that I'm going to have to go with here. For this problem, we're given the function ln of x over x for x greater than 0. We want to know which of the following is true. So we're talking about increasing versus decreasing. So to talk about this, I need to talk about f prime and where that's positive and negative. So to take the derivative of this, I'm going to be using the quotient rule. So here's our box and ribbon. We have a numerator of ln of x, denominator of x, and then their derivatives, which are 1 over x and 1. Using the ribbon to multiply that back out in my quotient rule, I have 1 over x times x, which is just 1. And then going back the other way, this is going to be minus ln of x times 1, or just minus ln of x. All of that over x squared. So now that I've got my derivative, I need to solve for critical values. So I've got two types of critical values here. We have the critical value where this derivative equals 0. And for that, we just look at our numerator. 1 minus ln of x is going to be 0, well, wherever ln of x has a value of 1, if we just add ln of x to the other side. To get rid of the ln, we just raise e to both sides, so we end up with x equals e, giving us that magic value of 0 for that derivative. And now we also have another critical value wherever this function is undefined. So at x equals 0, we're going to be, f prime is going to be dne at x equals 0. And also, to be honest, anything less than 0 as well is going to mess us up because you're taking the ln of a negative. Ln of 0 or negative, either way, would also give you not defined. So lots of good reasons that we should leave anything that's less than or equal to 0 out of our analysis. So when I'm doing my sign analysis now, I have, for my f prime, I've got a critical value at 0, and that's really where I'm starting. I don't want to look at anything less than 0, because again, that'll make our derivative undefined. The only other critical value is e, that makes this whole thing, this whole derivative 0. So testing out some values, this was a no calculator question, so I needed a value between 0 and e. I chose 1. That's pretty easy to plug in. So that's going to make my denominator positive. My denominator is always going to be positive because we're squaring stuff. Up here, ln of 1 is 0. 1 minus that is a positive. Next, we take a look at something that's bigger than e. So what's bigger than e that's easy to plug in here? Well, how about e squared or 3? That also works. Any of those kinds of things. So pick something bigger than e, plug it in. I know that ln of e is 1. 3 is a little bit bigger than e, so ln of 3 is going to be a little bit bigger than 1. 1 minus something a little bigger than 1 is going to give us a negative. So that determines the sign of the whole f prime here. And now doing my sign analysis, I see that my function is increasing on the interval from 0 to e because f prime is positive. Since f prime is negative after e, then we're going to be decreasing from e to infinity. So which answer choice matches that? So let's see here. F increasing for all x greater than 0. That's not true because we're decreasing. So let's keep looking. F increasing for all x greater than 1. Well, we're actually, 1's not even a critical value, so that doesn't enter the analysis. Same thing between 0 and 1. 1 is not a critical value, but let's just double check it here. So let's see, f increasing for all x greater than 1. We disprove that with this decreasing part. Decreasing for all x between 0 and 1. Well, we're increasing between 0 and 1 because 1 is smaller than e, and we're increasing from 0 to e. Decreasing for all x between 1 and e. We're increasing between 1 and e, so that's directly the opposite of what's happening. Choice E, decreasing for all x greater than e. Well, that's exactly what our sign chart says here, so we're going with choice E. On this problem, we're given this g function, and we want to know on which interval g is decreasing. So for that, I need to know what g prime is doing in terms of positive or negative. So g prime, if I take my derivative with the power rule, 3 times 1/3 cancels out. You just have x squared. And then here, 2 times 3 halves. The 2's are canceling, so this is 3x. and then this will be minus 70. 5 becomes 0, so we don't worry about it. So I want to figure out where this thing equals 0. To do that, I'm going to factor things that multiply to negative 70 and add up to 3. That would be, let's see, negative 7 and positive 10. So then we can say that x equals 7 and negative 10 for critical values. Let me put those on my G prime number line here. So negative 10, positive 7. Let's test out some things on each of these three intervals. Let's test out negative 11. That's going to give us a negative times a negative, which is positive. Let me test out 0 between these two critical values. That's a negative times a positive, which is negative. And something bigger than 7, like 8, that's going to be a positive positive, so positive. Now I want to know where G is decreasing. I always double check that. That's going to be wherever G prime is negative. G prime is negative between negative 10 and 7. So that's going to be our interval of decreasing. So that'll end up being, let's see here, answer choice D. For this problem, we're given f of x is x plus 1 over x. Seems innocent enough. We want to know the values for which f is increasing. So we need to know where f prime is positive then. So let me take my derivative. I'm going to start actually by rewriting this as x plus x to the negative 1. Make it a little easier to use my power rule. And then this is going to be, for f prime, we're going to have 1 minus x to the negative 2. Again, just using the power rule here from left to right. And I'm going to convert this into a single fraction in order to make this easier to do some sign analysis on and find critical values. So initially I write this as really 1 minus 1 over x squared, and then getting a common denominator of x squared. This is x squared over x squared minus 1 over x squared. So I can write this then as x squared minus 1 over x squared. And I need to figure out where this thing is either 0 or undefined for critical values. Let's start with the 0 piece of this. So this is going to be 0 wherever x squared minus 1 is 0. And that's going to be 0 if I add 1 in square root at plus or minus 1. So don't forget about the plus or minus when you're finding that critical value in square rooting. Now I notice I've got an x squared in the denominator. So this is also going to be undefined, DNE, at x equals 0. So this actually gives me 3 critical values for my sign analysis. Let me make a little number line. This is an f prime number line. And I've got negative 1, 0, and positive 1 as my critical values. So I have to test out values in each of these 4 intervals. Something less than negative 1 now, like negative 2. Let's test that out. And when I'm testing this out, I'm going to use this x squared minus 1 over x squared version of the derivative. Makes it a little bit easier. So my denominator automatically is going to come out positive because it's just x squared, and you're squaring whatever you plug into it. So it's really the numerator, this x squared minus 1 right here, that's going to determine everything. So if I plug negative 2 into this, this is going to come out positive. How about a number between negative 1 and 0, like negative 1/2? Well, that would give me a number that's less than 1 if I square it. So that would, if I'm subtracting 1 from something that's less than 1, that's going to come out negative. And if I have positive 1/2 between 1 and 0 and 1, and I square that and subtract 1, that still comes out negative. And then something bigger than 1 like 2, well, 2 squared minus 1 is a positive. So I wanted intervals where f is increasing. That's going to be this first interval from negative infinity to negative 1. And this last interval from 1 to positive infinity. So that's going to end up being answer choice A.